Today we're going to keep doing stoichiometry, okay, except we're going to introduce volume units and then particle, like molecule units. So first we're going to talk volume. When we measure the volume, what kind of unit do we use? In science, what kind of unit do you associate with volume? Good. Liters. Okay. So when we're talking volume, today we're going to talk liters or smaller quantities, so milliliters. Okay. And so first, let's just talk about volume and how gases behave real quick. Let's say we have a balloon, okay, and we blow up the balloon in this room. And then let's say we take it to a freezer. What's going to happen to the size of that balloon?
It's going to shrink.
Good. It's probably going to shrink, yes? And then what if we were to take the balloon from the freezer and go put it right by a fireplace? What's it going to do?
It's going to expand.
Okay, it's going to expand. So does the volume of gas change? No, our balloon, right? Can the volume change depending on like the temperature it's in? Yes. Okay. So when we do science and we're working with gases, if we're doing any sort of chemistry with gases here in Colorado where our air pressure is a little bit lower than 1 and it's cold, are we going to have the same volume of gases as someone who's like really warm and at sea level? No. Okay. So when we work with gases, we have to work in some sort of standardized condition. So we call that STP, which stands for standard temperature and pressure. Okay. So then that's how we make sure when we take measurements in one science lab, we're going to get the same data as a different scientist on a whole different area with different pressures and temperatures. Okay. So we standardize it. Standard temperature is 0 degrees Celsius, and then just 1 atmosphere of air pressure. So today when you see STP pop up, that's just a consistent temperature and pressure. Okay. And so for this unit, we're going to primarily keep our volumes at STP. And then in case you're wondering, like, well, how do gases behave when it's not 0 degrees Celsius or 1 atmosphere? As our whole next unit. Okay, our whole next unit will be gases in general. So then for today, this is the conversion we're going to use. So if our conditions are at STP, meaning 0 degrees Celsius and 1 atmosphere, 1 mole of gas is always going to take up 22.4 liters. Okay. And that doesn't matter what kind of gas. So 1 mole of oxygen gas is going to take up 22.4 liters. 1 mole of carbon dioxide is going to take up 22.4 liters. 1 mole of methane is going to take up 22.4 liters. Okay, so like that is a set number. It doesn't matter the type of gas. And so then today, our first calculation, we're going to do a mass to volume calculation. So we're going to follow the same plan. So we're going to go from grams to moles to liters. Okay, so it should be very, very similar to what we've already done. Okay, so we're going to do a mass volume calculation. Go ahead and copy down the balanced equation up there. All right, so then we're going to figure out how many liters of NO2 are produced if you react 22.5 grams of NO at STP. Okay, so this STP, it's only here to tell you you can use this 1 mole equals 22.4 liters. Okay, so that's the only reason of putting STP there, is just telling you can use that conversion. So now we're going to treat this problem just like all the rest. So first we're going to identify the given info. So what number is given to you? Okay, 22.5 grams of the NO, right? So I'm going to write it underneath NO in the reaction, just like we've done on all the previous ones. And then what are we solving for? Okay, so we're looking for the NO2. So underneath the NO2, I'm going to put my question mark. And this time I'm just going to put an L for liter. So far, does this look familiar, like how we've started all of the previous ones? Okay, before we just jump into the math, let's make a game plan. Are we going to start with NO or NO2? Okay, yes, NO. How do you know that?
Because it's the given.
Okay, it's the given. It's the one with the number. Okay, so we know we're going to start with grams of NO. Okay, and then what unit do you have to be in to get from NO to NO2?
Mole.
Okay, So we're still going to have to convert that to moles. And then once we're in moles of NO, we can get to moles of NO2. And then finally, what does your final unit have to be? So then we can get to liters of NO2. Okay, so now that we have our plan, we can do the dimensional analysis. So what number is going to go in the first box?
That'd be the 22.
Okay, so 22.5 grams of NO. And then if we follow the plan, we have to get from grams to moles. So what number do we use to convert between grams and moles? Okay, molar mass. So what's the molar mass of N and O?
30.01.
Good. Okay, so there's 30.01 grams of NO. And it's per mole, which is 1 mole. For every 1 mole of NO. Okay, now, what do we use to get from NO to NO2? We use the... Say it louder. Okay, that mole to mole ratio, which is 2 to 2. Okay. So then for every 2 moles of NO, we get 2 moles of NO2. All right, and then this is the new part. So now your final unit has to be in liters. So this is where we're going to use this new conversion. So 1 mole equals 22.4 liters. If moles of NO2 is up top, what unit has to go on the bottom? Okay, and the conversion has 1 mole in it. So I'm going to write 1 mole of NO2 on the bottom, and then 22.4 liters goes on top. Okay, and then we calculate it just like we've calculated all the other problems. Okay, so everyone practice, type it in your calculator, make sure you know how to get this final answer. 0.669 liters. Okay, what else are we getting? 16.79. Okay, so 16.79 liters. Okay. And 22.5, how many sig figs are there? 3, 30.01, 4. Do we ever count the whole numbers? No. The 22.4 is a measurement, so yes, we count that. How many sig figs? 3. So our lowest number has been 3. So what should we round our answer to? Okay, so we have 16.8 liters of NO2. Okay, so volume, we start with liters, we end with liters. Okay, so go ahead and copy down this equation. And then we want to know how many liters of oxygen do you need to make 19.8 liters of SO3. And again, this STP is just like your hint or your clue that you're using the conversion 1 mole equals 22.4 liters. All right, so then just like all the other ones, once you write down that balanced equation, let's write down the information that's given in the one we're solving for. So what number is given to you? Okay, 19.8 liters for the SO3. And then which one are we solving for? Okay, oxygen, also in liters. Okay. All right, so then this time for our game plan, are we going to start with the O2 or the SO3? Okay, SO3, and this time we're starting with liters. Okay. So we're going to start with liters of SO3. And then what unit do you have to be in to go from SO3 to O2? Okay, still moles every time. So we'll convert to moles of SO3. Then we can convert to moles of O2. And then finally, what unit should your answer be in? Are you feeling okay with this game plan? Here's the good news. I call this one the easy one because we don't have to find any molar masses, right? Do you see grams anywhere? Okay, so no molar mass, which to me, I think this is the easy one then. Okay, so now we draw our box. What number do you start with? 19.8. Okay, 19.8 liters of the sulfur trioxide. Okay. And you have to get to moles. So this is our conversion. So we're using the 1 mole equals 22.4 liters. If the unit liter is up top, what unit has to go down here? Okay, and how many liters? 22.4. Okay. So I'm going to write 22.4 liters of sulfur trioxide is equivalent to 1 mole of the sulfur trioxide. So now we're in moles. And how do we get from the sulfur trioxide to the oxygen? What do we use? Okay, that mole to mole ratio. So if SO3 is on top, what has to go on the bottom? Okay, and how many moles? 2. So we're going to write 2 moles of SO3 on the bottom. And then how many moles of oxygen? Okay, just 1 mole of oxygen. And then our last step is we have to get back to liters. So again, for every 1 mole of oxygen, how many liters will it take up? Good. Okay, so if mole is on top, 1 mole has to go on the bottom, which means the 22.4 liters has to go on top. Okay, this one could be super quick and easy to calculate. Will 22.4 liters and 22.4 liters cancel? Yes. Okay, these are going to cancel on their own. So we're left with 19.8 divided by 2. What's 19.8 divided by 2? 9.9? Okay. How many sig figs are in 19.8? 3 and 22.4? 3. So if we're short, what do you just have to add after the 9? Add a 0. So we're going to do one last one together. This time we're going to do a particle mass calculation. By particles are going to be molecules or atoms. Okay. Bless you. So again, same process, it's just I'm switching up that final unit. I promise it's a unit that we're familiar with though. So we're going to figure out how many molecules of oxygen are produced when 29.2 grams of water is decomposed. So go ahead and write down the balanced equation. Okay, and then what's the number given to us?
29.2.
Okay, 29.2 grams of water. And then what are we solving for? Okay, so I'm going to do a question mark under oxygen, and then I'm just going to say MC for molecules. Okay, so then we're going to make our plan. We're going to start with grams of water. And then what unit do you have to convert that to? Okay, so we have to convert it to moles of water. And then what can we convert to next? Okay, good. Moles of oxygen, and then your final unit, molecules of oxygen. Okay. All right, and then let's just refresh. For every 1 mole, do you remember how many particles or molecules there are?
6.02 times 10 to the 25.
Oh, you made me so proud. Okay, so we're just using Avogadro's number, and like that's a little familiar. Maybe you didn't memorize it, but like, have we seen that number before?
Yes.
Okay. Okay, now that we have our plan, are we ready for the dimensional analysis? Okay, what number goes in your first box? 29.2 grams of water. And then what's the molar mass of water?
18.016.
I'm going to round that to 18.02. Okay, so then we divide by molar mass to get us to moles of water. And then what's the mole-to-mole ratio between water to oxygen?
2 to 1.
Okay, 2 to 1. Since water's up top, it has to go on the bottom. Okay, so for every 2 moles of water, we're going to make 1 mole of oxygen. And then finally, we're going to get to molecules. If mole is up top here, what has to go on the bottom? Moles. And if you look at our conversion, it's 1 mole. Okay. So for every 1 mole of oxygen, there's 6.02 times 10 to the 23rd molecules. Okay, then we're going to calculate, same way you've been doing. Just a reminder, since we haven't talked exponents in a while, make sure you're trying to find that EE or E button. Okay, so you're doing like 6.02 E to the 23rd in your calculator. Okay, I promise it likes that button better than times 10 to the caret. Okay, 4.877 times 10 to the 23rd. Are y'all getting roughly the same thing? Okay, how many sig figs are in 29.2? Okay, 3, any less than 3 over here? Okay, so what should we round this to? Okay, so we take 4.88 times 10 to the 23rd molecules of oxygen.